equation for position of an object that is dropped from a height. And what we're going to do here is assume that the initial velocity was 0 and we're just dropping the ball, which simplifies our formula to -16 times the time squared plus the initial height. So when the object hits the ground, that means the capital H on the left here is equal to 0, and so now we have -16 t squared plus the starting height. So since we timed it and we had a 38.70 seconds at the end and 36.46 seconds at the beginning of the drop, we have a drop time of about 2.24 seconds. So if we put that in our equation, first of all I'm going to subtract the h sub 0 to the other side and then multiply both sides by -1, so I'll have that the starting height is equal to 16 times our t squared. And our t here is 2.24 seconds. So we're going to square that and then multiply it by 16. So we get our initial starting height at approximately 80.282 feet. Okay, so now that we know the height of the tower, we can replace the starting height with the 80.282 feet. Alright, and now if we want to determine what the velocity is when it hits the ground, alright, we would have to take the derivative of this. Well, h prime is going to be equal to the velocity, and when we take the derivative we get -32t plus 0. Alright, and now since we know what t is, we can go and put in the 2.24 and get our approximate velocity when it hits the ground at 71.68 feet per second. Alright, so we're not used to what feet per second is as much as miles per hour, so we're looking at feet per second. We're going to multiply that by the fact that there are 60 seconds in a minute and 60 minutes in an hour, and there's 1/5280th of a mile per foot. And if I multiply all this together and cancel, the feet will cancel, the seconds will cancel, the minutes will cancel, and I'm going to end it with miles per hour, and that comes out to approximately 48.9 miles per hour when the object hits the ground.